Michael will be with us shortly. My name is Greg Pickrell. Thank you very much. David, here's Michael, for your fantastic presentation. Always an amazing presentation. And yeah, really. And thanks to Bill McDonough for his video, which brings to mind, of course, the urgency of what we're doing here these days for the rest of our lives and the lives of our children. We want to have today a discussion, conversation, springboarding off Bill McDonough's video, and moving from value numbers to values, human values, moving toward quality and investigating that and what that means. So I'd like to present the panel today. Ann Mullins, Michael Fuller, Harry Teague. And we're going to have that discussion. Hopefully we'll have enough time to open that to questions and answers. Ann Mullins. Ann Mullins is a member of the Aspen City Council and a landscape architect and urban designer for the past 35 years. Her focus is on the built environment. This interest easily translates into a keen interest in urban resilience, especially with respect to climate change. Ann graduated from Wells College, Aurora, New York, with a Bachelor's of Science in Mathematics, and attained her Master's of Landscape Architecture from Utah State University, Logan, Utah. In 1984, she co-founded Civitas in Denver, Colorado. From 2004 to 2007, Ann was the campus landscape, Ann was the campus landscape architect for the University of Colorado at Boulder. Ann moved to Aspen in 2007 and has worked in private practice since that time. She is currently working with an emphasis on cultural and historic landscapes at her firm, WJM Design. And our next presenter will be Michael Fuller. I just want to get a bio so you guys have an idea here, then we'll present. Michael is known for his ability to bring elegance and harmony into his designs while maintaining a career-long commitment to environmental sustainability that goes back over 30 years to mentoring by Bucky Fuller, the WinStar Foundation, and the original Rocky Mountain Institute building in Old Snowmass. He's been responsible for the design, construction of commercial hotel and residential projects, land planning and development. He designed the first straw bale house in Aspen, the first 4-star Echo Hotel, the Inn, the Anasazi in Santa Fe, and the first LEED certified house in Aspen. Looking forward to hearing from you, Michael. And Harry. Harry Teague. As the principal designer and founder of Harry Teague Architects, Mr. Teague's work is distinguished by freshness of design approach and inventive planning strategies and attention to the craft of construction. His diverse practices include architectural design, site planning, industrial design, and community facilitation. An experienced builder, Mr. Teague has reinvented Colorado vernacular architecture and transformed it by his skilled and thoughtful introduction of contemporary materials and building technologies. So what I'm going to do with that, my name is Greg Pickrell. I'm a local architect. And all the folks up here are local architects, and happy to be here. I'm going to pass the clicker to Ann.
Oh, okay.
For your presentation.
Oh, there it is.
Okay.
Okay, well, thanks. Thanks for the introduction. And
You're welcome.
Chip, wherever you are, thank you for asking me to participate with this esteemed panel. I'm a landscape architect by education and an urban designer and planner by profession from over 30 years in the profession. I also have the added benefit, added insight into our discussion today by being a member of Aspen City Council. But we're talking about the built environment and how designers can actually form that. Landscape architects have a large, actually a huge role in the design of the built environment in the future and helping people live within their limits. We can affect large projects with immediate comprehensive solutions and other problems with smaller solutions that result in just incremental changes. But our immediate task, we need to take a step back and repair the damage that we've done to our environment in the recent past. And then with a healthier environment, we can approach a future with reduced energy needs and sustainable landscapes and developments. The Earth, the U.S. is scarred across, and these photos are from the photographer Michael Light, who documents American disasters, as far as I can tell. The Earth is scarred from mineral extractions. We need to reclaim these sites for the American landscape. In most cases, they cannot be used, reused, or repurposed, but there can be repair or reclamation. Our other task, then, is to reduce the need for energy consumption and support renewables, so this type of extraction does not happen in the future. And one more thing, we need to come up with a way that extractions that still need to happen, we can do this so that they're not destructive to our landscape. In the 60s and 70s and early 80s, and of course their slides are examples of each of these landscape developments, 60s, 70s, early 80s, there was unconstrained housing developments that resulted in enormous environmental change, not the least of which was a massive energy consumption. These sites can be repurposed, reused, and if necessary, abandoned, such as the right-sizing program in Detroit. Again, the other part of the task is to come up with a new model for housing based on diversity, multi-use development, transportation-oriented developments, infill, not sprawl, brownfields, not greenfields. And then our highways, parking lots, all the vehicular infrastructure has an enormous footprint across the US. While a lot of the infrastructure needs to stay, there are mitigation measures that can lessen its impact. And then the counter task in the other instances is to come up with a new transportation model, one that promises energy efficiency and ease of use. And last, of course, is climate change. It's here. As designers, we need to help people adapt to the change, help environments adapt to the change. And while we can't stop it, we can try to slow it down a bit. And where's forward this? Oh, there we go. So as designers, we have a lot of ways to create better built environments with new ideas emerging every day. One of the most effective tools we have is a green infrastructure. This used to be a narrowly defined term that was a alternative to gray infrastructure, concrete pipes, curbs and gutters to manage stormwater. The term has been broadened to refer to an interconnected network of green space that not only manages stormwater, but conserves natural systems and provides recreational opportunities for the community. It takes many forms. There's a list again. A green roof, a plant wall, an urban forest, street trees, rain gardens, city parks, permeable pavement, gray water irrigation, reconstructed wetlands, a green corridor through the city. And the upper side is a green infrastructure imposed on Philadelphia. Stapleton, the development at the old Denver airport, is one of the first developments to aggressively and actively use green infrastructure in its development plans by daylighting and restoring Sand Creek and Westerly Creek on the site. The benefits: carbon sequestering, water infiltration, groundwater recharge, surface water cleanup, temperature modification, diversification, just general environmental health. Excuse me. And while the connection between this and decreased energy consumption might not be immediately obvious, the more we can do to develop these natural systems to do the above, the less energy expended on design and engineered systems to do the same thing. And then, of course, urban design. This is a complex puzzle that needs to fit tightly together. Components are housing, transportation, infrastructure, open space, natural systems, employment opportunities. The sustainable model, most efficient one, is again one of diversity of choices for these various options, and providing platforms to allow partnerships and sharing of resources. We need to create a balance between built and natural systems so the natural systems can offset the impact of the urban development. And one other aspect of successful urban design is authenticity, maintaining character, retaining memories, creating memories, and connecting the community. As overused as the phrase is, sense of place is really a very important concept. A landscape, a city, it can't and won't be sustainable and livable if it's not valued and respected by the community. Transportation systems, these corridors and facilities are a major component of the urban landscape in the public realm. The bottom of the slide is the light rail in Denver. In our built environment, the future of these corridors will provide well-connected, easily accessible, attractive, safe, cost-effective options. Last mile connections are achieved through bike share programs and ride sharing, while regional connections need to move to BRT systems and light rail systems. Initiatives such as Complete Streets are programs that provide guidelines for these transportation alternatives. Aspen has added a new Complete Street chapter to its land use plan several years ago and is implementing this on its existing streets. And again, we need to take into consideration the changing landscape of the automobile. How do the requirements change for parking, road alignment, road design, refilling, recharging with the advent of autonomous cars and electric cars? Last, and this is not the last tool we have, but the last I'll talk about, locally sourced materials, plants, and food. Locally sourced reduces embedded energy. Local manufacture equates to jobs, employment. Locally, plants native or appropriate to the region reduce or eliminate the need for herbicides, pesticides, fertilizers. They're water efficient and support natural systems. Local food sources, again, minimize embedded energy, create jobs. And all this, again, results in a vernacular architecture, a regional landscape, a sense of place, and a valued aesthetic of place. And while our goal is ultimately to reduce energy levels, we also have a large part in supporting renewables. But again, there's a balance. The caution here is not to let the pendulum swing too far. We need renewables, but again, that needs to be balanced with the benefit of renewables and the impacts. Geothermal, as President Grimson knows, is one of the cleanest, most efficient renewables available. But it requires a lot of infrastructure, piping, access roads, structures, degradation to the landscape. Solar arrays and wind farms, they're efficient and more cost effective, as David pointed out, but a threat to wildlife in terms of bird kill and disrupting migration corridors. They can also be very detrimental to historic and cultural landscapes. Hydro is a clean, efficient source of energy. Aspen Electric is 100% renewable, largely due to the use of hydro. An existing reservoir has degraded the landscape, but a newly constructed reservoir irreversibly destroys the landscape. So we need to look to find the balance between these solutions. What we're doing is creating a mosaic of interconnected systems: the natural environment, urban environment, open space recreation, transportation, designed landscapes, renewable energy, and community. The solutions will be holistic and balanced and arrive through the collaboration of the various design professions. We can no longer afford to design for a single purpose. Design is optimism, and in this case, the optimism is the embrace of a possibility. It's the vision of a future that doesn't yet exist, but the ability to bring that future to life. And I think our other panelists can build on that optimism with the solutions and the work that they've done. Thanks.
Thanks, Ann. So, Michael, what do you have to say about that?
Well, I'm an architect, and guess what? I'm going to talk about projects. So, no surprise.
All right.
So I'd like to take a look at two aspects of architecting the future of the built environment. One's nature, and the other is human nature. First, I'd like to show excuse me, how renewable energy solutions by P4P Energy work with the natural environment. And second, as humans, we have an affinity, an innate affinity to connect with nature itself. And that's called biophilia. So how do we create a future built environment that does just that? I'll start with a tale of two bridges. Both these bridges are over the Hudson River near Poughkeepsie, New York. They're about a mile apart. And you can see the older bridge of heavy steel construction, and then the newer bridge using cable technology. The older bridges, they just don't build those anymore because they're probably twice the weight, have twice as many foundations. And so how does that translate into the built environment for the future. This is cable technology to support solar. And what that does, it creates the ability for long spans. And why is that important? Here's a condition of a canal. This is 3 million acre-feet of the Colorado River on its way to Southern California in the Imperial Valley, running a few hundred miles through a desert. Now, if you could cover that, you'd save millions, billions of gallons of water and generate electricity while you're doing it. So long spans matter. And so the span systems we're talking about can span up to 100 meters. And so in India, we're proposing to do just that. This is a Google rendering of an area in Punjab. And we cover hundreds and hundreds of kilometers with solar. So what that does, it creates kind of a solar highway. So along the way, you're delivering power to villages that may not even have electricity at the moment. And if they do, it's certainly not reliable. There's no such thing as a reliable power in India. Even Delhi and Mumbai have blackouts daily. So you also then can create an enterprise zone by providing power to these villages, and then run cable fiber optics along the spine, and then you have an information highway. And then the kids can be connected to the outside world, and they don't have to move to Mumbai or Delhi to see what's going on. So another thought in India, this is the Sidwan Dam, which is the, at the base of the Himalayas, and it's the origin for a canal that's 100 meters wide and over 200 kilometers long. And so we're talking to a company that built the hydro on this dam about covering the canal, starting at the dam, and then building out for a couple hundred kilometers potentially. So you take the savings, the water savings, and you pump it back above the dam during off-peak hours, and then you run the water that you've saved back through the dam at night. So you start getting a base load based on solar. So since it's such a lightweight system, you can put this over agriculture, and the long spans allow maintenance of agriculture through equipment, over parking. So in the future decades, I think it'll be quite common to see solar integrated into the built environment like this, over roads, over railroad tracks, over parking. So it becomes just integral with the way that energy is collected. And you'll notice no pictures of landscapes being taken out of use or harming habitat of any kind. So this is about building over existing or new infrastructure. So you don't actually have to deal with raw land for solar gain. So the next thing I want to talk about is human nature and our affinity for nature itself. And these are pictures of conventional buildings covered with plants, which is a beautiful way to encounter nature in the environment. But there's another way to consider nature in the built environment, and that is that the buildings themselves would operate more like living organisms. And so I'm going to take you through some slides, design of a project that considered those factors. So this was a project intended for the Middle East, a very harsh desert environment. These are some images of architectural elements you'd find: the onion dome, the use of graphics and patterns, the fountain or the well at the center of the courtyards. And so the building was intended to be a healing center, offering everything from yoga to MRIs, but for men and women. So you have separate but equal facilities in the structure. So using the five-pointed star a la Leonardo, represent the figure, masculine and feminine. They kind of reach over and hold hands and creates an organizing principle for the building itself. Then this represents the idea of compound at the center of spaces in the Middle East where the activities surround an open space, and then the well at the center of compounds and communities. So overlaying some of that graphics, it starts looking sort of like a floor plan, and then introducing a second skin on the building, recognizing we're in an incredibly harsh environment, and that skin would help modulate the temperature and conditions between the outside of the building and the interior, creating a space which we would use to grow plants. And so you would create an oasis, essentially. And now looking at the volumes, potentially using the onion dome shape, segmenting that into 5s, and then interlocking them. Sketch of a floor plan with a core made of traditional adobe structure, stone, adobe, so it acts as a heat sink, cool sink, actually. And then the arrangement of spaces around it with the central space as the gathering place, and then treatment facilities around that. And then the exterior modified to control the temperature and environment so that you could grow plants and herbs and medicinals. And so this is a cross-section sketch of a building where the air is actually drawn in around the perimeter, taken down into the earth where it's cooled by the natural temperature of the core of the earth, then drawn up through the central fountain in the core. It humidifies and cools it, and then that air is distributed throughout the building and then exits out through the perimeter where the green, growy plants are your surroundings. So you're in a building in a desert, 120 degrees outside, and you're looking at plants in every direction. So these louvers are intended to modify the climate within the building, and they operate and move according to season and according to the time of day. So they could be light shelves during one time of the day and block the sun when the harsh elements are present. Another time of the day, they could collect solar energy. They guide rainwater for collection. And so, a building like this incorporates living systems, really, to create a building that has lungs versus a HVAC system, or you could call it a skin instead of walls and a roof. They respond to the natural world, and they use natural systems to create delightful environments for people to live. And so it's not only connected environmentally and architecturally, but culturally, because embedded in the forms of this building are cultural aspects of that community, and also the elements around healing and the properties of nature. So I'm going to pass this along to Harry.
Thank you, Michael.
Wow, very. Thank you, Michael. That's beautiful stuff. And thank you, Anne, for your inspiring visions, and David for your process, and Bill, wherever you are, for your exciting work too. Thank you all for getting up so early in the morning and coming into this air-conditioned, artificially lit room on what is a really beautiful morning, and so on. I'm here as a provocateur. I'm going to wake you all up, I hope. And I've been doing this for 40 years, even longer than Bill McDonough. I went to Yale and I went to Dartmouth. I should be as great as him. I'm not, but I'm going to focus on something that I think is underutilized. We've been, back when I was doing it, we were making Thomason collectors, dribbling down corrugated sheets of metal into rusty pools, and making houses that were unlivable in some portions, and because they got too hot and so on. And I guess what I'm discouraged by, and where I'm going to provoke a little bit, is that we haven't gotten further. That we're still making rather ineffectual. We're not affecting the built environment in the way that we should. We affect a very small portion of it. When we do affect it, and no offense, David, but that beautiful little house that was made was not, a sexy building. It was practical. I'm sure it did all the right things, but it was like a Birkenstock or something. It did the right thing, but it was not terribly beautiful. And we're also, we have a system where we're making buildings where we're at the mercy of our clients as architects. if our clients aren't inspired environmentally, we're handicapped. We can educate them, we can sneak environmental qualities into a building, but as far as getting paid for it or them paying for it, unless they're really on board, this doesn't happen. I think that's one of our great big problems. It has to do with inspiration, it has to do with motivation in the world in general. And I see that as a place where we are not utilizing a rather major resource. We have the technologies. We have they're improving all the time. We have more portable, more interesting solar collectors, ones that could be stuck on pieces of glass and used in all sorts of ways. We have, as Ann was showing, rather beautiful ways of integrating environmental qualities into planning, but we're not doing them. And why aren't we, in fact, doing them? And that's because I think we're bogged down in a way in the metrics. Everybody in this room understands what Bill was talking about, what David was talking about, what we're all talking about. But we're all in the room. How do we reach the people out of the room? I'm a third-generation designer. My grandfather made cash registers sexy. He made vacuum cleaners sexy. He made riding in an airplane beautiful, a beautiful experience. I'm an evangelist for the capacity of design to bridge the gap between the really important high-quality work that gets done figuring out good policy, the extraordinary technological advances that we're making in terms of how to provide renewable energy and whatnot, and create that in a way that, in fact, is alluring, that in fact gets us out of the policy wonk mode and into the sales room or into the mind, so that the motivation to do this from our clients, from our voters, whoever it is that's actually making the choice, that this is done voluntarily. What is the bridge that actually happens here? Well, what we can bring to it is, number one, the visibility of the technology. By good design, when you think of a really good design, you think of something like, an object that the Shakers made, where they combined utility with an aesthetic quality. They took something as simple as a fork for stirring hay, and created it using the natural shape of a piece of wood, and carving it and working on it in a way that actually made it an object that we all admire. They took, and what's so interesting is that Michael was, doing exactly what I'm talking about, which is taking these things and making them really sexy and beautiful. But I really do. I mean, I think that's exactly what it is. But we need so much more of that. But the Shakers, again, took the design thinking takes a problem and applies other rather out-of-the-box solutions to it. Again, I use a Shaker example, the idea of sawing something. They like to try to apply a circle to a lot of sort of functional problems. And by applying the circle to the saw, they invented something like the circular saw. And it's beautiful in its utility, but it's also beautiful in its aesthetic quality. It actually, you know, people will put them up on the wall as decorations and whatnot. They have a quality to them. I think this is the sort of underutilized resource that can help us move forward in a I think a more sort of effective way. One of the other places that design create the bridge is in the interface. I know everyone here, we're all affected by design in so many ways, and in terms of achieving effective introduction of renewable energy, we need that same kind of interface. But let's take some of the ones, the troublesome ones. The seatbelt buzzer that goes on when it's not supposed to, you know, when you really don't want it to. It's telling you your seatbelt isn't. Well, I know my goddamn seatbelt isn't on. I'm trying to get my cell phone out of my pocket, right? I shouldn't be doing that, but I'm driving, right? Yeah. The idea, we have the capacity now to introduce smartness into a lot of our buildings. In a way, a thermostat is sort of a very primitive version of that smartness, very simple and very effective, but it has an interesting problem built into it that I think everybody's experienced. There's the person that walks into the room and it's cold, so instead of just turning the thermostat to 70 where they want the temperature to get to, they turn it to 90 thinking it's going to get to 70 faster without really understanding that the way the thermostat works, it doesn't understand that. Now we have new thermostats, we have Nests and things like that that are beginning to anticipate and learn about what we're trying to do. But as a designer, again, I think we have to be really careful. We have to look at what we're really trying to do and not get it overcomplicated. I go into somebody's house now, and instead of a light switch, there's a control panel with about 18 buttons on it, and you can't figure out which of the buttons you're supposed to push just to turn the effing lights on. So the design, again, in terms of our relationship, our human relationship to our built environment, should create that simple, that interface is a design problem that can be solved in an elegant way. And then further the sort of effectiveness of smart energy. I'm suggesting also that there's one of the key components in a good design is the ability, is the feedback. Whether it's the way a hand tool feels in your hand, or whether it's the way that you actually understand what your action is doing in a more subtle way. When you crank that thermostat up, if it told you exactly how much carbon you were producing, or better yet, how much it was costing you in the long run, that would be an extremely effective tool. I don't know thermostats that do that, but think about it. Think about the constant feedback. We were BSing in our preparation for this meeting, and we will relinquish $1 billion idea, but I believe in group sourcing here. So, and this is a little wristband that you wear that as you go around participating in life, it tells you and reinforces your actions. I think this is actually something that's quite doable. Right now you have a wristband that tells you how many calories you're burning as you walk around the house and so on.
Everybody's under an NDA now.
Yeah, that's it. But the idea that you would have you know, something that actually told you what the reaction is. Again, we're going back to that source, the source of the user, and giving them feedback about what they're going to do. I think most people, if they actually knew what they were doing, would probably be more responsive. So in a rather random way, I had it all written out carefully here, but as a usual designer, I think the main thing is to be mindful while we're participating in this discussion. And I guess what I'm imploring is that we that design is actually one of these tools that doesn't require any carbon to make. It has an infinite life cycle. It doesn't take embodied energy, and it can be. What am I trying to say? I just saw 10 minutes here. Yes, I got it. I'm done. But I'm just going to say, right. All right, so it doesn't require energy you actually use. It's our brains. What I'm imploring and what I seem to see is that we rely rather heavily on metrics. It's far too easy for us to take the weather data from the airport in Aspen rather than look out the window and see what's happening in our backyard. That we be mindful of the process on every level, whether we're making policy or designing an object, and that this particular thing I see as the thing that will further conscientious creation of a built environment. Thank you.
Thank you, Harry. Thank you very much. So design is offering poetry in the creation of a pleasing, sustainable environment. Pleasing and efficient, sustainable environment. As designers, we not only ask the questions of how, which are the metrics that we're all familiar with, but why. So I have one statement and a question for the panel. And the statement is a quote from Amory Lovins. People don't want raw kilowatt hours or lumps of coal or barrels of sticky black goo. They want hot showers, cold beer, comfort, mobility, illumination. It's like when you go to the hardware store looking for a drill. What you really want is not a drill, but a hole. As the end result, this is the value we're talking about. And he goes on to say that this is the first step in good design, is a call to value. So the question I have for our panel is, do people have to change their lifestyles to support sustainability? And what does that value look like in design? Michael, go ahead. You want to take that one?
Well, it's a fundamental question really about people changing their habits, and the answer right now is yes and no. We could sort of envision a future world where, I'll go back to the wristband idea because I happen to love that idea, but you're monitoring and getting feedback daily about when you take your shower or when you put a piece of toast in the toaster, you drive to work, what's going on. And that feedback is the Prius effect, where the feedback actually modifies your behavior. So what really modifies people's behavior? And I'd say it's access to technology, it's ease of use, cost. People are driven by cost. It's cheaper, better. And as Amy's pointing out, though, they may not mind how the service arrives at their door. I have a friend that's a rancher with a big pickup truck that hauls a big trailer. And so he was poo-pooing the idea of renewables and fuel and electric. And I said, well, if your pickup truck pulled your trailer and you got the gas mileage, you got twice the gas mileage, would you mind? And really thought about it and said, well, probably not. So it's about delivering services to people like the whole versus, and the infrastructure being constructed sustainably. And as designers, we're all designers, we are creating things that we see things that don't exist. And as a designer, we're putting things in the marketplace or developing concepts that allow people to live in a better life and a better world. And so right now there's trade-offs, but as designers, we're looking to design the future in which it's just the natural integration with nature and it's a sustainable system.
Okay, gosh, we're here already, 5 minutes.
So partly what you're saying,
Yeah, go
Michael,
ahead,
though,
Eric.
is that you want, that yes, part of the equation is in fact this motivation thing, that you want people to embrace the idea, but that they have to maybe want to do it in a way, right?
Or not mind.
Or not mind, right? Not even know they're doing it,
Right.
right?
I think that's the point. You
Yeah.
unequivocally have to change behavior,
Right.
and you have to sneak up on people so they don't realize you're changing
Right.
their behavior. And just like the systems we're talking about, you have to create a transportation system which makes taking your bike from your house to the bus to town, then the bike back to the work. You have to make it more appealing than jumping in your single occupancy car. And that's a tough one. And as McDonough said in his presentation, you don't want to tell everybody what not to do and where not to go and tell them you have 0 goals. You need to create a situation where they're happy to engage in this, even though they may not understand that their behavior is fundamentally shifting. And I think Gary made a great point. Designers can make things appealing. That's part of our job, to make them more accessible and attractive. But also creating a simpler interface with the natural system and built environment. Somehow get away of this array of buttons on the wall and voice-activated things, but really get people to re-engage with the natural environment, with the built environment. And just as Starbucks has a number of calories on every muffin, you can have a little menu of the carbon you're using when various activities during the day. There's got to be a reconnection of the population with what they're doing and the consequences of what they're doing.
Okay. We have about 2-3 minutes left.
Yeah, 3 minutes.
Something like that. I'd like to open this up to questions from the audience out there. Yes, sir.
How much solar and other renewable energy are you designing into the houses that you do around Aspen?
Did everybody hear that question?
Yeah. No, I mean, I think that's a terrific question, and I hope you heard, and I was not terribly articulate about it, but for one, there are, as we saw in David's thing, there are incentives for people to do that, various incentives and so on. But if our client doesn't want, let's say, to look at solar collectors on their roof, or doesn't like how they look, or doesn't feel that particular, maybe in a more sophisticated way, that actually putting the solar collectors on the roof in a place where they're on the shady side of the mountain doesn't make any sense. That, in fact, doesn't make any sense. So the answer is a sort of a complicated one. Certainly, we encourage buildings to do that if it's appropriate. But what I feel is that there's a almost one-size-fits-all mentality a lot that in fact may not be completely appropriate for that building to do that. We have other options in town as well. And I think that's something that, we also have tons of sun. I mean, when it's appropriate, absolutely, there's no question. But I guess my answer is whenever possible and whenever, the client agrees and so on.
Thank you, Harry. That's great. Yeah. Yes, sir. Another question.
I actually have 2 questions. The first question is a statement an architect have to acknowledge, which, I'm an architect, that there's a difference between creating sustainable habitats and making the architecture produced by the paradigm of the modern movement and the modern city and its value of urbanization, globalization, etc., sustainable. That needs to be challenged. There needs to be a deeper looking at the history of habitation, which is very regionally connected, and looking at that as sustainability. The second question is, solar panels have developed as they've developed, but what is the next step? And I'm asking the question, is it possible now to make solar panels more sculptural so that they can be applied for instance, some of the images shown today were from the Middle East, where you had geometrical designs, ceramic forms. Is it possible to invent and sculpt solar panels so they can take on different forms than the one that we know up till this point, and be used in innovative ways so that they can become more integrated into the architecture of the building as opposed to being an applique.
To
Go
speak
ahead, Ann.
very
Yeah,
quickly
please,
to,
yeah.
to your second question, there's all sorts of ways of using solar arrays. There are systems now where they're embedded into road systems, so that they're not sculptural, but they're less visible and just, integrated into the environment.
Well, for photovoltaics, they're actually totally manipulatable and so on. They're flexible now. You can get films and things that
There's
can
even
make curves. But
Paint.
for
right.
thermal collectors, then they're a little bit more complicated to do that way. But I'd say there's ways of doing that. I think that's one of the issues. But I guess where I really wanted to make a point was that there are places where large sections of solar arrays, they're happening here already, solar farms, photovoltaic farms and so on. There's ways of storing energy, thermal energy underground and using that in a very efficient way. There seem to be a lot of other options than just sticking solar collectors on the roof. I'm all for them. I've been doing it for 45 years. But is that really the right answer in every case? And I'm just asking us not to default, but to think about this. Building is a very individual thing, and each building has its own problems.
Thanks, Harry. I'm sorry we're at the end of our limit. Thank you, Harry Teague, Michael Fuller, and Ann Mullins, and thank you, everybody, for participating today. Appreciate it.
Thank you.